Hello, grade 11s. Welcome back to the channel. In today's lesson, we're going to be looking at functions and we are dealing with parabola and exponential functions. So as I've told you before, guys, the trend with grade 11 functions is that they mix up these functions. So you might find a parabola mixed along with a straight line or a parabola mixed along with an exponential graph, as we can see with this one here. So, okay, now let's look at this question, what we are given here. It says question 6, and we are doing it from DBE November 2018. This is your question 6, right? So in case you want to go and check it, right? The diagram below shows that the graph of f of x is equals to negative bracket x minus 3 and then square plus 25, and g of x is equals to 2 and then bracket 1 over 2 to the exponent of x plus 1 minus 4. So we can tell that this is the parabola graph in the turning point form, right? So we know that we are used to it in this form, ax squared plus bx plus c. But then remember, there is the standard form. There is the root form, which is like this. This one, if you are given the roots and any other point. And then there is this format here, which we call it the turning point form, right? Then, and g of x is this. So we can see that this is an exponential graph because it is given in the form of abx plus q, right? Y is equals to abx plus q, right? So now we are told that graph f cuts the x-axis at a and c, right? As we can see here, the graph of f being the parabola graph cuts this graph. It cuts the x-axis at point A and point C, right? And then and has a turning point at D. So we can see the turning point there. And then graph G cuts the x-axis at A and y-axis at B, right? So we can see the exponential graph there cutting at A and then also as well cutting at B, right? Then we can see E here is the y-intercept of the parabola graph. So now that we've analyzed all that, let's get to the question. Guys, it is very important that when you are given this, you analyze your the given diagram here, right? So that you can see that everything relates to what you've been given in here, and then it also helps you to better understand and try to form conclusions in order to answer your questions. Then 6.1 says write down the equation of the asymptote of G, right? So we know that this is an exponential graph, and an exponential graph has a horizontal asymptote. The horizontal asymptote is always given by the constant here. As we can see here, there is a line down here which represents the point where your exponential graph will never touch. So this point given from this equation, we can see that it is -4. So to write the equation of the asymptote, we say y is equals to -4. And then that's what you need to do for that 1 mark, right? Then 6.2 says write down the coordinates of D. Now note, every time they say write down, guys, there is no calculation involved. That means it is something that you need to just observe either from looking at your diagram or from reading the statement and seeing the equations of the graph, right? So D here is the turning point, right? So D will be representing the coordinates of the turning point. But since we said this format is the turning point form, we know that from that format we can get the x coordinate and the y coordinate of the turning point by saying if we have x minus 3 here, we know that if we have a negative, we must straight out write this one as a positive, because it's more like we are taking whatever the contents of the bracket and equating to 0. So our x coordinate becomes 3. So that means the x coordinate for D is 3, and the y coordinate will be the constant here, right? So this number here always stands for the y coordinate of the turning point, right? So we have our coordinates as 3 maps to 25, right? So those are the coordinates for D, right? So note that there was no calculation involved. I simply looked at what I was given there. So let's proceed. Okay, now 6.3 says write down the range of f, right? So the range of f is this one. Note with the range, guys, if we are given a concave down graph like this, we know that a concave down will come from an unknown minimum value, so from negative infinity all the way up until the y-coordinate of the turning point, right? Remember, range, what do we say is the range? The range is all set. This is all set of possible y values, right? All set of possible y values. So that is to say the graph of f will exist for this y values from negative infinity. Remember, this arrow means that this graph starts all the way below there and then goes all the way up and tends here. So that means this is the final y coordinate that we'll have. But then remember, the coordinates that we got from here were 3 is to 25. So that means this graph starts all the way from negative infinity up until positive 25. So how are we going to write that? To write the range, we say y is an element of round bracket, because you cannot include the negative infinity. Remember, we don't even know what's that negative infinity. The negative infinity all the way up until 25. Then square bracket, because 25 is included. Remember, 25 is also a value for this graph of f, right? So you can either write it that way, or if you prefer this method, you just say y less than or equal to 25. So that means for all the y values that are either equals to 25 or below 25, which is similar to this one where you say y is an element of negative infinity all the way up until 25, right? Then calculate the length of EB. Let's see that one. So to calculate the length of EB, note that this will involve you having to find the y-intercept for the graph of f, and then also the y-intercept for the graph of G, right? Because E here represents the y-intercept for the graph of f, and B here represents the y-intercept for the graph of G. Now, once you find that, you must then find the difference between this y-intercepts, right? So let's try to calculate that one. How are we going to approach it? So this is how we're going to approach this question. First of all, let's try to calculate the y-intercept for E, right? So we are given the equation up here. We are given the equation. So up there, we are given the equation of f and g. So to calculate the y-intercept, we mainly make x 0. Then we go y, and then is equals to negative, and then where this x, we put 0 like that, then plus 25, right? So what are we going to get for that one? Our value, if we punch all this in a calculator, is equals to 16. So that means the coordinates for E are 0 is to 16. Remember, this is y-intercept. Then we take the graph for G, and then we say, okay, G, to calculate the y-intercept, once again, we must make x 0. So this is y is equals to 2. And then where we see x, we just simply substitute our 0 there. And then like that, plus 1, and then minus 4. If we punch all this in a calculator, the value that we get for that one is equals to negative 3, right? So that means the coordinates for B are 0 is to negative 3. Now, if we want the length or the distance between EB, this is what we're going to say. Remember, this is 0. So from this point of origin all the way up here, this is 16 units, right? But then from the point of origin all the way down to B, this is 3 units downward. So what is the length or the distance between those? So you only need to say the distance. We will say this is 16 plus 3, right? And then it will give us 19 units, right? So that means EB, the length of EB is equals to 19 units. Okay, so we have it like that, right? Or you can even simply say 16 minus, because if you want the distance, you simply take this one, subtract by the value here. So even if you can say 16 minus negative 3, you'd still get the answer as 19 units, right? So either way, you will get that value. Okay, Then we have 6.5. It says determine the values of x for which f is decreasing, right? For which f is decreasing. So now let's look at this, right? If we want to find the values of x decreasing, let's understand this. If we have a less than 0, the graph that we have is concave down, right? And then this is what we have to understand. From x element of negative infinity all the way up until the x coordinate of the turning point here, we will see the graph increasing. But then from this point here all the way to positive infinity, we will see the graph decreasing. That's if you have a concave down graph, right? But then if you have a concave up graph, the opposite happens. All the way from negative infinity up until the x coordinate of the turning point, we will see the graph decreasing. But then from this x coordinate of the turning point all the way to positive infinity, we will see the graph increasing. Now, if we have to go back to the question, it says, determine the values of x for which f is decreasing. What is happening here? We can see that from this point here going all the way. So if we can just break it down, because now we understand that a graph will increase up until the stationary point or the turning point and will decrease from the stationary point, right? So now let's look at this. We can see that all the way from negative infinity up until that stationary point, the x coordinate of that stationary point, what is the graph doing? It is increasing. So if you were to put a ruler here or a straight line, you will see that it will give you a positive gradient. It will be like this. So that means your graph is increasing like this. But then we are not looking for increasing, we are looking for decreasing. So that means it starts to decrease where? From this point here. So from the stationary point, or from the turning point, from the x coordinate of the turning point all the way to positive infinity, we can see that the graph here is starting to decrease, right? So how do we write that? We say x element of a round bracket positive 3 all the way to positive infinity. And note that I'm using round bracket because 3 cannot be an inclusive value, because at 3 the graph is not increasing, it's not decreasing, it's just stationary there. So you must be careful in terms of writing this. When they say increase, decrease, you don't use square bracket, you simply say from x greater than 3 all the way to positive infinity. So it's for all the values that will be greater than 3. So you can even write it this way, x greater than 3, right? And then just like that, you are correct. So 6.6 says calculate the average gradient between point A and B, right? So to calculate the average gradient, we do understand that first we need to find the coordinates for A and then also find the coordinates for B, right? So that means we will need to use these equations once again, right? So in order to find the average gradient first, let's find the coordinates for A. Now we can see that A there represents what? It represents the x-intercept, right, of the turning or of the graph of f, right? Even also the graph of G. So at this point, we can see that this is the point of intersection because it exists in the graph of G and it also exists in the graph of F. But again, it is the x-intercept, meaning if it's the x-intercept, we can make y 0. So it's just a matter of having to choose which equation do we want to use. So we can go with the simplest one, this one here, and just say, okay, if we make y 0, this is 0 is equals to 2, 1 over 2x plus 1, and then minus 4, right? So you can see that y is 0 because we are trying to calculate the x-intercept. Bring over this 4 here would be positive 4, 2, and then like that, then x plus 1. At this point, we can divide by 2 both sides to get rid of this 2 here. And then this is 2, and then 1 over 2x plus 1. Right. Now, at this point, we need to write this in terms of base 2. So 1 over 2 can be written as 2 to the exponent of negative 1. Right. And then we still have this exponent here, x plus 1. Now this will give us 2 and then negative x and then negative 1. Now the bases are the same. We know that here there is an exponent of 1. The bases are the same. We can simply just drop down the exponent. So this would be 1 is equals to negative x minus 1. Now if we take this x over to the side, this would be x is equals to negative 1, and then take this one over. So it's x is equals to negative 1 minus 1. This is x is equals to negative 2. So the coordinates of A are negative 2 is 2, 0. But then remember, when we were calculating the length of EB, we did calculate the values for B, right? We did calculate the values for B, and we found that the values for B were 0 is 2, negative 3. Now that means if we have this coordinate, we can now calculate the average gradient. So calculate the average gradient, you simply need to say y2 minus y1 over x2 minus x1. So we use the gradient formula. Then if we are taking this as y2, this would be negative 2 minus 0. So this would be x2 y2, and then this is x1 y1. So this is negative 3 minus 0, and then here we have 0 minus negative 2. So this would be negative 3 over 0 minus this, that's positive 2, so negative 3 over 2. And that will become our average gradient, right? So this is how we find our average gradient. So, okay. We are killing this. Let's see. Bring it on. Then we are told here graph T is obtained by reflecting G about the x-axis. Write down the range of T, right? So we are told that graph T is obtained by reflecting the graph of G about the x-axis. So if you are reflecting the graph of G about the x-axis, that means we are reflecting it along this line here, right? So I need you to understand this. If we are reflecting along the x-axis, we are reflecting it along this line. So what this normally does is that it will affect the y coordinate, right? So for example, this will now come out like this, right? So this will be, the reflection will give us something like this. So that means our coordinates for B here, where 0 is 2, negative 3. If we are reflecting this along the x-axis, what happens is that this coordinates here, if we have B, let's say if we have K, for example, as a reflection of B along the x-axis, what K will be is 0 is to positive 3. So I hope it makes sense. If you are reflecting something about the x-axis, so a reflection about the x-axis affects the y coordinate. So it affects the y coordinate. That means even our horizontal asymptote here will be affected. So here we had y is equals to negative 4. So if we are reflecting this about the x-axis, that means our new asymptote will be equals to what? Y is equals to 4, because simply a reflection along the x-axis takes the y-coordinate and changes its sign. So if the y-coordinate was negative, it now becomes positive. If it was positive, it now becomes negative. So hence they're saying here, now write down the range of T. So how do we write the range of T? Now we have to say, remember, we have to consider what was the range of G first. The range of G would be y greater than negative 4. So this simply means that the graph of G would start to exist for all the y values that are above the asymptote. So for y greater than negative 4, because you will never find this graph here below this asymptote. So the graph of G would start to exist at a point that is above negative 4 being the asymptote, going all the way up to positive infinity. But because we've reflected it along the x-axis, now what happens? The asymptote is above at positive 4, meaning the graph of T being the reflection of the graph of G will now start to exist from all the values that are below positive 4 going downward to negative infinity. So how do we write the range? The range this time will be y less than positive 4. Or you can write it as y element of negative infinity all the way to positive 4 and round bracket, because positive 4 is not an included value. Why? Because positive 4 will be the asymptote, and the asymptote is where the graph will never touch, right? So I hope it makes sense. Then done with that. Now let's look at 6.8. It says if p of x is equal to f of x plus 2, so this plus 2 here, what does it represent? This is a translation, guys. So if you are given something like this, we are given p of x is equal to f of x plus 2. That's saying if the graph of p is a reflection of is a translation of the graph of f 2 units upward, right? So this is a translation. This is a translation. Remember, all this fall within transformation. So this is a translation. I will also do a video specifically just explaining more about transformations, which involve your translation, and reflections, right? Then if p of x is equal to f of x plus 2, write down the coordinates of the turning point of p. Now, in order to answer this question, it is very important that you know what were the coordinates originally, right? So originally the coordinates for f were the turning points for f were 3 is to 25, right? So this is what we get. Now they want the turning points for the graph of p. This is a translation. This is what we call a vertical translation. So it only affects the y coordinate here, right? So that means this is more like pushing the graph. The graph of p would be more like we just pushed it further 2 units upward, like this. So this is how the graph of p would look like. So the turning point would still be in the same x coordinate, but then just now it will be 3 is to 27 because we are pushing it 2 units upward. Hope it makes sense. So this is a vertical translation, or what we call a vertical shift, right? So it has been shifted 2 units upward. So that means the turning point for p, for the graph of p, would be 3 is to 27, representing that the y coordinate here has been shifted 2 units upward. Hope it makes sense. Now, 6.9 says determine the values of k for which the straight line y is equals to 2x plus k will be a tangent to f. Now, guys, I want you to understand this question here. This question is very common, and then a lot of learners always have a challenge answering this one. Now, I want you to understand, if you are watching this video and you have reached this far, this is a secret that you will unlock from this video, that in order to answer these questions here, you need to apply the rules for nature, the nature of roots, right? So the rules that apply here are the nature of roots. Now, note this: a tangent needs to intersect with that graph, right? So they say determine the value of k for which the straight line y is equals to 2x plus k will be a tangent to f. In order for the straight line to be a tangent to f, it needs to intersect with the graph of f at a particular point, right? Now, if this straight line intersects with the graph of f at that particular point, we call that particular point the point of contact. Now, what we know about the point of contact, every time they mention point of contact, or they mention the point of intersection. So point of contact and point of intersection all mean the same thing. Every time they mention this, we know that we have to equate the two equations, right? So this is what we know from this. So now I'm saying that the tangent needs to intersect with the graph at a particular point. We don't know as yet what that point will be, but then let's just assume that if we draw it here, the point of contact will be somewhere here. Now, what do? because we know that at the point of contact, the two graphs needs to be equated. That means we will take the equation for the graph of f and then equate it to the equation of the tangent here, right? So let's do this. So let's have our point of contact here. Remember, we are assuming that the point of contact is somewhere there. Now, what do we do? At this point, we can say that the graph of the tangent and the graph of f of x can be equated. So that means f of x equals to graph of tangent. Right, let's just put it that way. So we can take this equation here, negative, and then x minus 3 square plus 25, and then equate it to this equation here. Now, you might be wondering, now we have two unknowns. We have x is an unknown, and then we have k is the unknown, which is why we need to apply the nature of roots. So bear with me as I take you through this one. So having to solve this one, if we expand here, this will end up being negative. So this would be x squared minus 6x and then plus 9, then plus 25 is equals to 2x plus k. So if we multiply with this negative outside, this is negative x squared plus 6x, then minus 9 plus 25 is equals to 2x plus k, right? Then at this point, what we can do is bring over this here, right? So we have negative x squared plus 6x minus 2x, and then we have negative 9 plus 25 minus k is equals to 0. So this will end up being negative x squared plus 6x minus 2x is 4x. Then if we do this, that's plus 16, but minus k is equals to 0. Now, at this point, you can see that you have something that is in quadratic form. Right. So applying the nature of roots, we'll just go on and say a is equals to negative 1, and then b is equals to 4. Remember, b is the coefficient of x, and then a is the coefficient of x squared. Then c will be whatever that's remaining here. So 16 minus k. Right. Now, at this point, we are saying that the tangent is one point of intersection. That means if it has one point of intersection, it will represent two equal roots. So if something has only one point of intersection, it's more like it represents two equal roots. Now we know that for two equal roots, that's where we have our discriminant being equal to 0, right? So if our roots are rational and equal, remember our discriminant is equal to 0. From the questions that we answered from equations and inequalities, if you still remember that. Then what we are going to do now is to say b squared minus 4ac is equals to 0. Remember, this is the discriminant we are talking about. So what is our b? It's 4. So we have 4 squared. And then what is our a? Negative 1. Then our value for c is this expression here, 16 minus k is equals to 0. So at this point, we are now looking for the value of k. Note that we are no longer dealing with x here. The only unknown that we now have is k. So we have solved the part that we have two unknowns. Then this is just, it will give us 16 and then plus 64 from multiplying this negative 4 times negative 1 times 16. And then this will give us minus 4k, right? So this would be minus 4k. Then is equals to 0, right? Now at this point, what do we do? So this is going to be 16 plus 64. That should give us 80. If we cross over to that side, that's going to give us 4k. And then if we divide both sides by this 4, then our k will end up being equals to 20, right? So this would be equals to 20. So the diagram below shows the graphs of f of x is equals to negative x squared minus x plus 6, and g of x is equals to mx plus c. And then a is negative 2:4, is the point of intersections of the graph, right? So we are given that this is the point of intersection, and then we know at the point of intersection, this is where the two graphs meet, right? So the x coordinate and the y coordinate for these two graphs are the same at that point. So, okay, now we can see that the a here is less than 0, negative, hence we have a concave down graph. So make sure that you analyze your diagram correctly before you even start answering the question. Now, looking at this straight line here, we can see that this is an increasing function. So we can tell that our gradient here needs to be greater than 0 or needs to be positive. So, okay, now that we've analyzed, let's try to answer the questions that we are given. 6.1 says determine the x-intercept of f, right? So to determine the x-intercept, we know that all we are required to do here is to make a y 0, right? So remember, for x-intercept, what you do is make y 0. So that means we're going to take this equation here and equate it to 0, right? Now, at this point, we can divide everything throughout by -1. So we're going to end up with x squared plus x, then minus 6 is equals to 0. At this point, we can have x plus 3, and then x minus 2 is equals to 0. So our x-intercept would be x is equals to -3, or x is equals to 2. Now, looking at where B is, we can see that the coordinates for B needs to be -3 is to 0. And then the coordinates for C needs to be +2 is to 0. Right. Now, the turning point is somewhere here, right? So that makes perfect sense, right? So we are done with that one. We have calculated the x-intercept, and then we've also wrote them in form of coordinates. Then 6.2 says, write down the equation of the axis of symmetry, right? So what is the axis of symmetry? Note this. So the axis of symmetry is more like the midpoint for this x-intercept, right? So you can easily calculate the axis of symmetry by saying, let me calculate the midpoint of the x values, right? So if you say the midpoint of the x values, this would be -3 plus 2 divided by 2. -3 plus 2 is 1, so you have 1 over 2. Or if you don't use this one, you can simply go with the formula. The formula to calculate the axis of symmetry is this one. So this formula, guys, I know that you mostly use it to calculate the turning point, but understand the x-coordinate of the turning point is actually the axis of symmetry. So this point that you see here is the axis of symmetry. This is where we can cut this parabola graph into 2 equal halves. Then the y-coordinate is the one that is actually the turning point, right? So at this point, we can say we have this, our A is -1, then our B is also -1 as well, then our C is 6, right? So now that means we can substitute negative, and then we have -1 here, then 2 times -1. So negative and negative, that's positive. So this will give us negative from here, -1 over 2. So that's our axis of symmetry here. So that's our axis of symmetry. Even here, so this is negative, and it's not positive, it's not +1, it's -1. -3 plus 2 is -1 over 2. So yeah, my mistake there. So that's -1 over 2. Then let's proceed. Now, 6.3 says, write down the range of f, right? So in order to write the range of f, we can see that we are given 3 marks here. In order to write the range, we have to consider this. If we have a concave up graph, then the notation to write the range is to say y is either greater or equal to the y coordinate of the turning point. And then if you have a concave down graph, you say y is either less than or equal to the y coordinate of the turning point. This stems from the fact that we know that this graph here, this parabola graph will exist from this minimum point all the way to positive infinity. But this one here will exist all the way from positive infinity and then will end at the maximum value of this one, right? So this has a maximum value while this one here has a minimum value. So this starts from a minimum value all the way to positive infinity being the maximum, but this starts from the minimum value of negative infinity all the way to a maximum value, which is represented by the turning point. So the situation that we have here is concave down, right? So that means we would need to find the y-coordinate of the turning point. So how are we going to get that one? Remember, we already have, so note that these questions here are always follow-up questions. We are using whatever that we calculated previously to calculate whatever that we are required. Remember, we have the axis of symmetry is -half, but the axis of symmetry is the x-coordinate of the turning point. Meaning we can use this one in order to find the y-coordinate of the turning point by simply substituting -half where x is, right, from this equation. So -half and then square, then minus, we have -half, then plus 6. At this point, all you need is your calculator. So you're just going to simply press all this in your calculator. So let me quickly do that. So we have that, and then we have this, and then plus 6. So it's giving me 25/4, right? So that means, how do we write our range? So we already have the y-coordinate here. So this is our turning point, -1/2 is to 25/4. So in order to write our range, we'd say the range is y less than or equal to 25/4. Or you can write it in this notation, y is an element of round bracket -infinity all the way to 25/4 and then square bracket. Square bracket because 25/4 is also an included value because the graph reaches that point. Now, 6.4 says write down the equation of G in the form of Gx is equals to mx plus c. So what are we going to do with this one? Note, again, it proves the fact that we are dealing with questions that are always in terms of follow-up questions, right? So note that we've already found the coordinates of the turning point, but then the graph of f and g intersect at 2 points. It intersects at the point A here, but then again it also intersects at this point here, which is what this point here, which is an intercept. Now, in order to find that, that means we will need to calculate the value for d there, right? So how do we calculate the value of d? This is quite simple. Looking at the fact that at point D, this is the y-intercept. We know that the y-intercept in a parabola graph is always represented by the constant here. Even if we can say to calculate the y-intercept, we need to make x 0. All we'd have to do is substitute 0 where x is, and then you'd see that this leaves us with this 6 here because all this will just give us 0, and then we'd be left with 6, right? So the coordinates for this D here would be 0 is to 6. Now we have the coordinates for D, and then we also have the coordinates for A. -2 is to 4. This is all that we need in order to calculate the gradient. So to calculate the gradient, we only need 2 sets of coordinates. So we'll say the gradient of AD is y2 minus y1 over x2 minus x1, right? So this would be 6 minus 4. So taking this one, subtracting that, and then this would be 0 minus -2, so that's 0 minus -2. This will give us what? 6 minus 4, that's 2, and then this is also 2, so this will give us 1, right? Now that we have this, we can now write the formula that goes y is equals to y1 is equals to mx minus x1. So if you haven't seen this formula, it appears in the back of your formula sheet. So you do not have to memorize it. All you have to know is how to use it. Now, at this point, what you do is you choose which coordinate you want to work with. You can either substitute the coordinates of A or you substitute the coordinates of B. Either way, it will be correct. Then you say, y, let's say, suppose we are substituting the coordinates for D, which is 0 to 6. So we'll say y minus the y1 represents the y value, and then m is the gradient. Then we leave the x1 represents the x value, so that's 0 there. So we have y is equals to 1 times x is x. 1 times 0 is just 0, so we transpose this -6, it becomes +6, right? So that means just like that, we have our equation is y is equals to x plus 6, right? Now, if you are curious as to whether if we substitute the coordinates of A, we'll also have the same answer, we can also do that one. Y minus y1 is equals to mx minus x1. Now, let's substitute this coordinate. This would be y minus 4. And then our gradient is still 1. And then this is x. This is -2. So it's minus. It's going to be +2. Right. Now at this point, we're going to have y is equals to 1 times x is x. 1 times 2 is 2. If we transpose this -4, it becomes +4. So this is y is equals to x plus 6. Right. So it is still the same answer, guys. So it doesn't matter which coordinate you choose to substitute, as long as those coordinates are part of what is on the straight line, right? So the coordinates of A are on the straight line, the coordinates of D are on the straight line. What would be wrong is to use this coordinate, the coordinates of the turning point, because the coordinates of the turning point are nowhere on the straight line. They only appear on the graph of F. Okay, then so 6.5 says now write down the average gradient between A and D. So that's saying write down the average gradient. Remember, we have already calculated that. So let them not confuse you by saying write down the average gradient. What we calculated here was that average gradient. So the gradient here is equals to 1. Hence, it's even 1 mark, right? Then 6.6, determine the equation of H. If H is the reflection of F about the x-axis, and then translated 3 units to the right. Leave your answer in the form of hx is equals to ax plus p squared plus q, right? So what we want to do with this one, first, let's go to the graph of F and try to write this equation in the form of the turning point, right? So remember, we have already calculated the coordinates of the turning point here, and then we found that it was 1 over 2 is 2, 25 over 4, right? If we are to write this in turning point form, this would give us y is equals to ax minus p squared plus q, right? So where our a is already given is negative, so we have negative. But remember, the p here stands for what the coordinate or the x coordinate of the turning point. So that means we have x minus 1 over 2 and then square. Then the q here is always the y coordinate of the turning point. So we have 25 over 4. This would be our f of x. Originally, in turning point form, this would be the equation for f of x. But then remember, they said this is reflected along the x-axis. So number one, there's a reflection along the x-axis, which we know that this affects the what? The y coordinate. And then again, we have a translation 3 units to the right. So let's check. So they said this was translated 3 units to the right. So this is what we are going to do now. Let's start with the reflection. If we are reflecting this about the y-axis, this is how we must express this. A reflection along the x-axis looks like this. If I have f of x reflected along the x-axis, and then we are forming a new graph, h of x, that means h of x has to be equals to negative f of x, right? So originally we have our f of x. If it is translated about the x-axis, what happens is that we put a negative before the equation of f of x. So that means the new equation h of x would look like this. So this would be h of x is equals to negative, and the whole of f of x is this. So negative x minus 1 and then square plus 25 over 4, like this. So this negative here will affect the negative here. So this becomes positive. But then note it does not affect the one that is inside. Then the negative times positive is negative 25 over 4. Right. So now we have solved the part that this is reflected along the x-axis. So it was reflected along the x-axis, and then we did see that it affected the y-coordinate by this negative here. Now we are not done. This needs to be translated 3 units to the right. So if this is translated 3 units to the right, what needs to happen is that this needs to be x minus 1 over 2, and then a translation 3 units to the right. That means we are taking this value in here and then we are adding it to 3. So basically this means all we do here is say x minus 1 over 2, then plus 3, right? This is the reflection 3 units to the right, then minus 25 over 4. So this will give us x, and then we have plus minus 25 over 4, right? Then let's look at 6.7. It says write down the value of x for which f of x is greater than 0. Now with this one, you need to interpret this, understand what f of x greater than 0 actually means. So if you are given this, it is best to interpret it. F of x greater than 0 means where f of x is above the x-axis. So where is the graph of f of x above the x-axis? Now, when we interpret it that way, it becomes easier for us to read it from the graph, right? So we can see this is f of x, and then we are looking for the points where we see the graph being above this line here. Remember, this is the x-axis. So where do we find it being above? We can see that it's above from this point here up until this point at C. So what are the coordinates here? There were negative 3 is to 0, and then here we had 2 is to 0. So that means this is for x element of negative 3 all the way to positive 2. So from this x values, in between these x values, we can see that your graph is above the x-axis. And that's how you write it. Then 6.8 says if f p is equals to fr is equals to 4, calculate the value of p minus r if r is less than 0, right? So here, this simply means the function of f when x is equals to p and the function of f when x is equals to r, right? So all that you have to do is go back to this formula. So they told you that all this must give you 4, right? So that means we can simply say if we have f of p, then that means wherever I have x, I must substitute p, right? Wherever I have x, I must substitute p. Then this is equals to 4. So this will give me negative p squared minus p plus 6, right? But then again, f r. So where there is x, now I substitute r. And then this should also give me 4. So now, looking at this, if we try to solve this, let's bring all this over here. This is p squared plus p. And then if we say 4 minus 6, that's minus 2 is equals to 0. So this would be p plus 2 and then p minus 1. is equals to 0. And then here, also for this one, this would end up being r squared plus r. And then if we say 6 minus 4, 4 minus 6, that's minus 2. Then this will give me r plus 2. And then r minus 1 is equals to 0. So my p here is equals to -2, or my p is equals to 1. And then here I have my r is equals to -2, or my r is equals to 1. But then they said calculate the value of p minus r if r is less than 0, right? So if r is less than 0, that means we cannot use this value here for r, right? So r less than 0, that means this one is not applicable, because we are looking for where r is negative. So in order to calculate that, what are we supposed to calculate? The value of p minus r. So p minus r can either be this p here, -2 minus -2, which will just give me 0, or we can calculate it using this. This is 1 minus -2, which will give me +3, right? So obviously, because between p and r, there must be that distance in between them. That means the correct value that we are looking for is 3, right? Because that's where we want to get a definite value. So 1 minus -2 is equals to +3. So, yep. And we are done. So make sure to hit the thumbs up button and then subscribe if you haven't subscribed yet. Then also share the link with your friends and classmates so that they might also find assistance. Remember, we are winning as a team.